Okay, so for question number one, it says, using the figure to the right, name one example for each of the following. It asks for a major arc. By definition, a major arc is an arc that measures more than 180 degrees. So it's going to be greater than half of the circle. So one example of a major arc here would be arc YUX. If you were to go along the circle, Y starts here, U is up here at the top, and you go all the way around past the halfway point. You know Y to S is halfway. So if you go past that, you're more than 180 degrees. So one example of a major arc would be arc YUX. When you name an arc, you use that notation. It just looks like a piece of a circle. For a semicircle is exactly half of a circle. The easiest way to find a semicircle and know you've got a perfect semicircle is to identify your diameters. The diameters are always going to give you two semicircles. So your first diameter, well, your diameter rather is segment YS right here. So your first diameter can be up here, arc YUS. Arc YUS is a diameter. Then, is a semicircle. Then you have another one. The one down here on the bottom is also a semicircle. There. You can call that arc YVS, arc YWS, you can also call it YXS, or you can say it in reverse. You could call it SVY, SWY, SXY. Either of those would be acceptable. Put the phone up. All right, so when you name a semicircle, you use 3 letters. You name it using where it starts, anything on the way, and then you name it using where it ends. If I'm trying to name the semicircle on the top, again, it starts over here at the Y. You can use the T, the U, but you have to stop using whatever's at the end, which would be your X. All right, the last thing to talk about on this one is a minor arc. Well, minor usually means something small. Well, in a circle, a minor arc is an arc that measures less than 180 degrees. So it's going to be one of the small arcs. There are several minor arcs here that you could choose from. Arc YT. YT is a minor arc. Another minor arc would be TU. Give me another one.
SX.
Okay. Arc SX.
Did you say YW?
Let's see, VW. What else?
SX. Oh, you said that.
Okay, we got that.
XW.
You can do YW. You get the hang of it though, right?
Yeah.
Minor arcs are your small arcs. They're named using only 2 letters. So if you see an arc that is named with 2 letters, you should automatically know it's less than 180 degrees. It's going to be a small arc. Okay? Now, the only reason you need to know this specifically for this test is because you're going to be asked to name or to find the length of an arc. And they might say find the length of a minor arc or find the length of a specific major arc, but they'll tell you what you need to know. You just need to know that major arcs are going to be bigger than 180 degrees, semicircles are exactly 180, and your minor arcs can be anything less than 180. Okay? All right, let's see, next question. Question number 7 says, what is the exact area of the circle represented by the following equation? And then they give you the equation for the circle. The key for this is you need to know the formula for the area of a circle. What is the formula for area of a circle?
2 pi r squared.
Let's try it again. Pi r squared. Area equals pi times your radius squared. Now, if the formula is area equals pi times the radius squared, you have to think about the equation that they gave you. They've given you everything in this equation that you need to know to finish this problem. You need the radius to find the area of a circle, right? How can you find the radius of a circle from what's given here?
It's like the square root of it.
Oh, wait a minute. You telling me I should divide?
Square root.
Thank you. You want a square root, but take the square root of what?
R squared. 55.
Take the square root of the 55. Now, here's the deal. That 55 is your radius squared. The standard form for a circle is x minus h squared plus y minus k squared equals the radius squared. When it's in this form, whatever you have here is your r squared. In this case, our r squared is what? It's 55. Does everybody understand that? If our r squared is 55, do we really even need to find r? Can't we just put 55 right here?
Yes.
Okay, let me go through that one more time for some of you who look confused. This number, the 55, is your r squared. You know that because that's what it tells you over here. R squared always goes on the after the equal sign. So if our r squared has already been given to us as 55, you can plug that in over here. So that area equals pi times, we know r squared is 55. So when they ask us for the exact area, exact means we have to leave it in terms of pi. So our area is 55 pi. And did they give us any units? No. So we say units squared, because area is always squared. And that's the answer. All you had to remember was that that equal sign tells you what your r squared is, and then plug the r squared into your area formula. All right, so the next one that you asked for, does everybody have this copy? Okay. Okay, so for number 8, it says the graph of a circle has a center at -6,4 with a radius of 4. And they want us to tell if that point is inside the circle, outside the circle, or on the circle. And they want you to justify it algebraically. Well, the key for doing this is to remember basically what they're giving you. So what you have is your center is at -6,4. We're just going to sketch a rough graph over here. You know what? Let me change this. Okay, so what's happening here is our center is at -6,4. So you know you're going to go over 1, 2, 3, 4, 5, 6, and then go up 1, 2, 3, 4. So this is approximately where your center would be located at -6,4. Then you have a radius of 4. What do I have to do with that radius to graph my circle?
You gotta
I
put
go-
the circle on there.
4 in every direction. 4 units to the right, 4 to the left, 4 up, and 4 down. And then I'm just going to sketch in the circle. So if I count, I'll go 1, 2, 3, 4 to the right. That's going to put me about right here. 4 to the left. 1, 2, 3, 4 puts me about right here. 4 down. 1, 2, 3, 4. 4 down and then go up 1, 2, 3, 4. So about right here. And then you just sketch in your circle. Now again, I'm just doing this freehand, so my circle is far from perfect. Just pretend that it's perfect. So if that's my circle, they're asking me if my radius is 4 we really want to know if the point -8.5 is inside that circle, outside the circle, or on the circle. You could obviously look at it on the graph and see -8.5, negative 1, 2, 3, 4, 5, 6, 7, 8, and then up 5. 1, 2, 3, 4, 5. That's going to be somewhere in here, about right here. That's obviously inside the circle. And all I did was sketched it. But they're not asking us to just sketch it and then say where it's located, even though that is always an option, as long as the numbers aren't too big. What they want you to do is find the distance using what you know about a circle. Well, first of all, if the radius is 4, that means anything that is within 4 units of that radius is going to be inside the circle. Anything that has a distance greater than 4 units away from the center is going to be where? It's outside the circle. If my length or the distance from the center to that specific point is exactly 4, that means it's going to be on the circle. So what I need to do is figure out how far is the point -8.5 away from -6.4. So to do that, you can use the distance formula. The distance formula, you may or may not remember, but square root of x2 minus x1 squared plus y2 minus y1 squared. So you can do it algebraically that way. If you do that, you do need to label your points. You can let this be x1, y1. This will be x2, y2. All right, so you can help me out. I need to plug in.
Alright, you ready?
Yes, I am. What's my x2?
-8.
All right, so -8 minus, what is x1?
-6. Yeah.
What is y2?
Yeah, +5.
What is y1?
4.
Okay. What happens with these two negatives? It becomes a plus. So I actually have -8 plus 6. What is -8 plus 6?
-2.
All right, so that's -2 squared plus 5 minus 4 is?
1.
So 1 squared. -2 squared is? 1 squared. So I end up with the square root of 5. Now, the decimal value for the square root of 5 is approximately 2.1, if I'm not mistaken. Do that for me.
I got you. All right, ready?
2.2? Okay, so it's approximately 2.2. So what we now know is that the distance from the point -8.5 to the center of the circle -6.4 is only 2.2 units away. So clearly, if it's just 2.2 units, this new point right here, your -8.5 is inside the circle because it's less than 4 units, which would be the radius. Okay? So you can do the distance formula for every one of those, but you do the distance from the center to the new point to see how far they are. If it's less than 4 units, it's inside the circle. If it's greater than 4 units, it's outside the circle. And if it's exactly 4 units, that point would lie on the circle. Got it? Okay. Okay, so for number 10, it asks, what is the ratio of circumference to diameter for a circle with a radius of 4? Well, first thing you need to know is, what is the circumference? So the formula for circumference is C equals what?
2 pi r squared?
Not squared, 2 pi r. So circumference is C equals 2 times pi times the radius. Now in this problem, what did they say the radius is?
4.
So circumference is equal to 2 times pi times 4. So this circumference would be 8 pi. I'm gonna leave it right there, because it just makes it easier to operate when I don't have a bunch of decimals. So 8 pi is my circumference. Now the diameter would equal what?
8.
All right, your diameter is 2 times the radius. So that's 2 times 4, which we know is 8. Now, I can take this, the circumference is 8 pi, put it up here. Your diameter is now 8. So when they ask for the ratio of circumference to diameter, Your circumference is 8 pi, so you have 8 pi divided by your diameter, which is 8. What happens to those?
They cancel.
The 8's cancel out. So if your 8's cancel, your ratio of circumference to diameter is just plain old pi. Like always. It's always going to be pi. If you do the math correctly, that is.
Okay. You don't have to do that, or just be like, it's gonna be.
Okay, can I move to the next one?
Sure.
All right.
Please go. Get lost.
All right, for number 12, the question on number 12 on your paper, it asks you to write the equation for the circle that's given. So in order to write the equation of a circle, you need two things. What are the two things you have to have?
The center and
All right, you need the center, and you're going to need to know what the length of the radius is. All right, so in this case, you can look at the circle and figure out where the center is. Where is the center?
In the middle.
Exactly where in the middle?
Is it 1, 2? Is it 1 and 2?
Let's see. We're going to try right here.
Whatever you want.
Now, if I try this, I'll know if I'm right, if the distance to the right of it, which is a radius, would be the exact same as the distance to the left. Okay, so let's count. From this, it's 1, 2, 3, 4, 5, 6. If I'm correct, it'll be 6 units on the left side. So 1, 2, 3, 4, 5, 6. So is that going to be our center? Yes, it is. If you need to check one more time to be sure, you can count the distance going up and down. If it's the same, you know that this is definitely the center. So what's the coordinate for this center?
1, 1.
All right, so our center is at 1, 1. Now, we already know the length of the radius is 6. So to write the equation of the circle, don't forget your standard form. X minus h squared plus y minus k squared equals r squared. And then you just plug in. So remember, when you plug in, you keep the numbers and do what to the signs? You change them. What do you do with the radius? You square it. All right, so when I plug in, that's going to be x, what? Minus 1 squared plus y minus 1 squared equals 36, because that's 6 squared. And that's your answer for this problem. Any questions? Okay, so question number 16 says for you to write the equation of a circle if you're given the center at 4, 1 and a point on the circle at -8, 6. Well, in order to do this, you need to remember the standard form, which is x minus h squared plus y minus k squared equals the radius squared. So what you need to find,
That was Kyrie Johnson. I don't know what that meant.
you need to find the length of your radius. You find the length of the radius by plugging in. Your center is your h and your k. Your point on the circle is your x and your y. You're going to take the h, the k, the x, and the y, plug them into the standard form, and use that to find the radius. So when I substitute in here, what is x? So -8 minus h, which is? Okay, so -8 minus 4 squared plus, what's y? 6 minus what is k? 1 squared equals r squared. -8 minus 4 is? Alright, so -12 squared plus 6 minus 1? -12 squared is 144. 5 squared is 25 equals r squared. So 144 plus 25 is 169 equals r squared. What is the radius? 13 equals the radius. So you would have to take the square root of the 169 and the r squared. Now, that's just the radius. We still need the equation for the circle. So to get the equation of the circle, remember you use the center, which is at 4, 1, and you use the radius, which we just found is 13, and you plug back in to the standard form for your circle. So when you write your equation, that's going to be x what? Minus 4. Okay, x minus 4 squared plus y minus 1 squared equals 169. Because that's your 13 squared. Any questions on that one? Any questions at all? Okay. All right, let's see the next one. All right, so completing the square. All right, so completing the square, if you remember, this was pretty simple. I told you that to complete the square, your goal is to create a perfect square trinomial. And you do it by taking half of whatever your middle term is, and then you square that. What you get after you square it, you're going to add to both sides of the equation. So in this case, we have an expression, so we don't have to add to both sides, but we do still take half of the middle and square it. So for this one, what is half of this? What is half of this middle term? You take the -7, you square it. What is -7 squared? 49, so that 49 goes right here. Over here, for example B, x squared plus 3x plus blank. Again, take half of the middle. What is half of 3? Okay, how did I tell you I wanted you to do these, to make it easier? Make it a fraction, so it would be 3 over what? 1. 3 over 2 for half? Yeah. Okay, 3 over 2, and then square that. 3 over 2 squared is equal to what? So the 9 over 4 goes right here. The thing that you need to remember is once you've created the perfect square trinomial by completing the square, these things factor very easily. If I wanted to factor the x squared minus 14x plus 49, remember I told you it's going to factor to give you two of the exact same things?
It would be wrong if you don't use fraction.
You're not wrong, but generally the fractions are just easier to work with when you're doing this part. But it's not wrong. Okay, so again, if I needed to factor this out, remember it factors to be x minus 7 squared. You always put the number that goes right here, I told you should always be the number you get when you take half of that middle term. Okay? Okay. Yes. Yeah. All right, for number 21, 21 and 22 are just alike. The only difference is 22 is asking you to graph it after you find the equation for the circle. So remember the notes that I gave you on this? I actually still have them right up here on the board, so you're going to have to pay attention over here. If I needed to rewrite that equation, the x squared plus y squared, hold on, let me erase that. All right, x squared plus y squared minus 8x minus 6y plus 21 equals 0. So I need to rewrite that so that it's in standard form, and this you definitely need to know for your test on Monday. The first step, look at the paper over here on the other side of my smartboard. What does step 1 tell you you should be doing? All right, you group the x's. Good. Group your x's and group your y's. And then if you still have a constant on the left side, you need to move it over to the other side of the equation. So when I group the x's, my x squared goes in here, minus 8x. Then your y's go over here, so y squared minus 6y. This 21 also needs to be moved, but when you move the positive 21 to the other side, what does it become? It becomes a negative, so that's gonna be minus 21. Now you can complete the square, like the examples we just finished doing. You're gonna take half of your middle term and then you square it. In this case, the middle term is a negative 8. What is half of that? All right, so you're gonna take that negative 4 and square it. What is negative 4 squared? 16. What do I do with the 16? I add it here and where else? And the other side of the equal sign. Okay? Then for this one, you got y squared minus 6y. That's negative 6y is your middle term. Half of that would be what? So negative 3. And then you have to square that. What is negative 3 squared? So your 9 is added here and here. Now you created your perfect square trinomial. In creating the perfect square trinomial, this is going to factor perfectly. What does it factor to be? All right, x minus 4 squared. What does this y term factor to be? Y minus 3 squared. Now, some of you are not paying attention and you need to be. Y minus 3 squared equals, I know over here, 16 plus 9 is 25, and 25 minus 21 is what? 4. So now it's in standard form. Yes, ma'am.
So you got negative 4 and 3 from
Half of the middle term.
from half and
Yep. That's just a shortcut. That obviously mathematically that's not the correct way to explain it, but it works. So if that helps you to remember how to factor it, then that's what you can use. It works. Okay? All right, so now, this is our equation in standard form. What is the coordinate for the center? 4, 3. All right, the center is at 4, 3. And what is the radius? The radius is 2. Now, don't forget, to get your center, you take this same number here and change the sign. Take the same number here and change the sign. For the radius, you take the square root of that number. All right, so now you got your center, you got your radius. If I need to graph that, what do I have to graph first? All right, you graph the center. So that's at positive 4, positive 3, which is right here. It's a little bit off because my calibration is off, but you get the idea. So 4, 3 is there. And then what do I have to do after that? Count 2 in each direction for the radius. So, let me try to move that over. All right, so 4, 3. 2. Okay, sketching your ellipsis circle. That's so off. Oh, sorry, that's a very ugly circle, but you get the idea. All right. All right, so let's go to number 22. Determine the center of the circle. You're going to do the exact same thing that you just did in number 21. You're going to complete the square and find your center after you put it in standard form. Who wants to talk me through this? All right, go ahead, I'm listening.
so first, x squared minus 12x,
Mhm.
and then plus y squared minus 18y,
Okay, what you know is you do need to move the 5 over, right? Well, you can do 6 minus 5, because you already have a 6 over here. So if you do 6 minus 5, what would be left on that side? It'd be a 1. All right, just for everybody who may have been listening on the video, you're gonna group your X's, group your Y's, and then remember you need to subtract this 5 from both sides. So when you subtract it from here, it's gone on the left side, but 6 minus 5 on the right side leaves you the what? Okay, now what? Okay, and half of negative 12 is what? And what do we do with that? And what is that? What do I do with that 36?
And then on the other side, you get half of.
Okay, so I added after the 12x, but is that the only place I'm supposed to add it?
Oh, yeah.
Thank you, gotta add it to the other side. Okay, so plus 36, all right, now what?
Then you go to the Y's, so you get half of 18, negative 18, which is negative 9.
All right, so that's negative 9, and then we,
Square,
which is,
81.
and what do we do with the 81?
Add on both sides.
Okay,
So, this is, 36 minus 12 is 20. So x squared, no, x plus 24. No?
okay, remember, when you write the factors here,
Oh, yeah.
what should this be? What kind of 6?
Negative 6.
Thank you, x minus 6. The easy way to remember this number in the factor is always half of that middle term above it, okay? All right, so x minus 6 squared plus, what is this?
5 minus 18. I mean 9
X minus 9.
squared. And then on the other side.
Okay. Is that in standard form now?
Yeah.
Okay, so it's in standard form. Once you have it in standard form, then you can get your center. What is the center for this circle? That's it. Everybody okay with that? All right, for number 23. 23 says, Billy is creating a circular garden divided into 8 equal sections. The diameter of the garden is 12 feet. Now, the thing I need you to think about is this. They're asking you to find the area of one section of the garden. They're asking for the length of an arc, and they're asking for the length of another arc. Well, in order to do that, you need to know 2 things. You need to know the measure of the arc in degrees, and you need the length of the radius. So they didn't give you the length of the arc here. I'm sorry, they didn't give you the measure of the arc, and they did give you something you can use to get the radius. But think about a circle. How many degrees are in every circle? 360. So if a whole circle is 360, and this one has been divided into 8 equal sections, what do you know?
Divide by 8 and see the angles of each one.
You're going to divide this circle by 8. So divide the 360 by 8. And then that'll tell you what each of these arcs is. So 360 divided by 8. How many degrees is that? 45 degrees. So every single one of these angles in here will be 45 degrees. That means every single arc in here is 45 degrees as well. So you got 45 degrees for this arc, 45 degrees for every other arc in that circle. You probably got it and left it on the desk. Go on the side stack over here. All right, now, they told us all right, so every single arc every single angle is 45 degrees. The problem said that the diameter of the garden is 12. Pick that up, Cameron. If the diameter is 12, what's the radius? The radius will be 6. All right, now, question A says, what is the area of one section of the garden? So, if they're asking me to find the area of one section, you need to recognize that one section is really a sector. Remember we talked about a sector is like a slice of pizza? It's a part of the circle that's bounded by 2 radii and an arc. So if I want the area of one of these sectors, what's the formula?
Wait, what do you have?
We are.
Oh, it's 45.
Okay, wait. What's the formula? Pi r squared times
M divided by 360.
m over 360. So we did m, which is the measure of your arc, divided by 360 times pi times your radius squared. Now, just for the record, on your formula sheet that you get to use, they give you that formula like this. They have the pi r squared theta divided by 360. That is the exact same thing as this. This theta means the measure of your angle. So we write it as our m. That theta means your m, or your angle measure. So let's plug in. What is the measure of your arc in this problem?
0.125.
The arc is 45 degrees. Remember up here? Each arc is 45. They asked the measure, the area for one arc.
I don't know, but I love you. I had to do that.
Okay, but what I'm asking for is the m.
Yeah. I think.
Okay,
Is it 45?
let's back up here. I showed you up here that the whole circle is 360, and it's divided into 8 equal sections. So if you do 360 divided by 8, that's 45 degrees per arc. So that's why our m is 45. Okay,
I just ain't know how to do it.
so you've now got 45 divided by 360 times pi times your radius. What's the radius? It's 6, and you got to square it. So 45 over 360 times pi times 36. You can go ahead and multiply all of that out. Multiply straight across the top and then divide by 360. They didn't ask for the answer in exact form or in terms of pi, so you don't need to worry about reducing fractions. Just go ahead and multiply across the top and divide. What's the answer?
14.14.
All right, 14.14. Since this is an area problem, this is going to be in square feet. Any questions on that part? Okay. All right, for part B, it asks for the length of arc AC. All right, so let's look at arc AC. AC starts here at A, and it goes around the circle here to point C. I'm just highlighting it to make it easy for you to see. Now, since they're asking me for the length of that, the formula for the length of arc AC is m over 360 times what?
2 pi.
Times 2 pi r. Now, here's the thing. In order to figure out the m for this one, you need to look at your picture. How many different sections is this? It's 3 different sections. If each of those sections is 45 degrees,
Should we time that by 3?
yes.
Gotcha.
So that whole thing would be 135. Does everybody agree with that? So your M is 135 divided by 360 times 2 times pi. No, I didn't. I said put my pass back over here. Times your radius, which is 6. Now again, you are not asked to write this in terms of pi or in exact form. So you can just multiply your numbers and your pi across the top and then divide everything by 360. Leave it right there. Put my pass back over here on my desk. I appreciate you, but thank you. It's the same thing we got the first time. And this is just here. I'm sorry, say what? I can't hear you. Would be what?
No, would it be for A to C for B? Would it be 84.82?
All right, for part C, it asks, what is the length of arc ABC? Since we're finding length again, same formula as we did in B. Excuse me. So for part C, L equals M over 360 times 2 pi r. The question is, what is the length of arc ABC? So again, you have to look at the picture, figure out what is the measure in degrees of arc ABC. So I'm gonna highlight it. ABC starts over here at A. It goes around the circle through B, and it stops here at C.
So you
Now.
have to multiply.
Now, the question you should be asking is, how many sections is this? 45 times,
6.
45 times how many?
6. 8. Oh, that's 5.
I'm talking about arc ABC.
Oh.
ABC is 1, 2, 3, 4, 5 sections. You get that?
That's counting.
You said 5.
Did I not say 5?
I heard. So you take the 45 times 5. 45 times 5. That's going to equal 225. So that's our M. So when I plug in, that's going to be 225 over 360 times 2 times pi times the radius, which we know is 6. Now you can multiply straight across the top. Multiply 225 times 2 times 6 times pi. And then divide by 360. And what do you get? I'm sorry, what is it? Thank you. 23.7, and these are feet. Yes. For number 26, it said, find the area of the non-shaded region. So we're basically finding area of a sector. What is the formula for area of a sector?
A equals M over 360 times radius squared times
No,
5.
man, it's pi.
Pi squared.
All right, M over 360 times pi r squared.
Oh, pi squared is 7.
Now, the question says the area of the non-shaded region, so you have to think about what they're saying. They've already told us that this arc is 160 degrees. So if this is 160, what is this going to be over here?
140.
It's 200.
Yep.
Now, if you're wondering why it's 200 degrees, remember, the whole circle is 360. You already have 160, so you just subtract. Okay, so the unshaded region has a measure of 200 degrees. Now you can find everything else you need. Your M is 200, so 200 divided by 360 times pi,
Or square.
and your radius is what?
Square.
And you need to square it.
Can we go over 24 and 25?
So if I multiply or square the 10, you've got 200 over 360 times pi times 100. Now you can multiply straight across the top and straight, and then divide on the bottom. What is your answer for this one? One 74.5?
Yeah.
And this is area, so the units will be squared inches. Any questions on that? Any questions?
Amen.
All right, number 28. All of you who have your heads down, pick them up. Y'all look like y'all don't have a test on Monday. Number 28 says, find the length of the major arc. So the key thing is they're asking for the length of an arc. The formula for the length of an arc will be what?
M over 360 times 2 pi r. Yeah.
Okay, so that's your length formula. Now, the major arc is the arc that's greater than 180 degrees. Well, this one is 135, that's a minor arc. So the major arc is the one that's left, the part that's not shaded.
Come on.
Okay, if your question is on number 28, we can talk about it. If not, you'll have to wait and I'll go back.
Yeah, it's on 28.
What's your question?
I feel calm,
All right, so if I plug in, what do I have to do to get M for this one?
Subtract the minor arc 360.
All right, so you're gonna do 360 minus the minor arc, which is 135. What is that?
224.
All right, so
Yeah.
the arc is 225 degrees. You're gonna use that as your M. And the radius is 6. Okay, what do I do now?
You multiply 225 times 2 times 5 times 6.
Okay, so if I multiply straight across, 225 times 2 times pi times 6, and then divide by 360, what do you get?
When did you tell us to start? That you had to subtract which
She just told us.
I don't remember doing that. I always remember just doing.
Just being given the arc?
Yeah.
Well, I figured that's just one extra step, but you can handle it, can't you?
I mean, but I didn't know. I got all these problems wrong. You feel me? So it's like, I don't know what to do.
Okay. All right, so this one, what shape is this? What kind of pyramid?
Rectangular pyramid.
Thank you. This is a rectangular pyramid. Okay, so since this is a rectangular pyramid, then you already know what the base is, and you already know what your formula should be. What formula are we going to use to find the volume for this?
Volume equals 1/3 times base times height.
Okay, now is it just regular base, or is it,
Area. Big B.
thank you, it's big B, which means area of the base. So 1/3 times the area of the base times the height. Now the key for this Big B is going to change depending on the shape of your pyramid. In this case, my pyramid is a rectangle. I mean, the base of my pyramid is a rectangle. So when I do big B here, I use the formula for the area of a rectangle. It's length times width. So big B is length times width.
And that equals.
So, hold, one second. For this pyramid, the base is down here.
What?
This is the rectangle that we're gonna be working with. The dimensions for that rectangle would be 8 and 7. So that's what you use to find your big B. So 8 times 7 equals 56. So the area for the base of this pyramid is 56. So when I plug in, I have 1/3 times 56 times the height. What is the height of this?
6.
6. Remember, the height of a pyramid is the distance from the vertex of the pyramid to the base. So this segment is your height. All right, now. If you multiply straight across the top, 56 times 6 is 336.
Yes.
And then you divide that by 3.
112 inches square. Oh,
Not
cubic,
square.
cubic.
Okay. 112 cubic inches is your answer. That's not so bad. The thing you have to remember, I told you, anytime they come to a point, if your figure comes to a point, like a cone or a pyramid, you divide by 3. You always find the area of the base, whatever that is. So you have to analyze the picture, figure out what shape is that base, and then use that to find the area. And then you go from there.
Why is it that we divide by this?
Yeah. How you doing? Yo, yeah.